discuss. Let me take it. So the first question is this. If f of x is equals to, we are having k cos x. If x not equals to pi by 2 and okay, k cos x by pi minus 2x is there. And here 3 is there if x equals to pi by 2. Okay, the given function is continuous at x equals to pi by 2 and hence find the value of k. Okay, it is already given in the question that the given function is continuous, yeah, at pi by 2 and hence find the value of k from here. What can be done over here, Fatima? If it is continuous at pi by 2,
so you can equate them.
we can equate the left hand side, right hand side, left hand limit, the right hand limit, and the function's value at pi by 2 all has to be same, right?
Yes.
Let's do it. Suppose we are doing it quickly, the way we do, finding the limit. Left hand and right hand, we can see it's same, right? The function is same. Okay, so quickly how we find limit x tends to pi by 2 and k cos x over pi minus 2x. Can you calculate and let me know what are you getting, Fatima?
Is it 0?
Is it 0? And the function's value at pi by 2 is?
3.
So 0 is equals to 3, is it? Is it
No.
true? And here is strictly written, find the value of q. Okay, this is completely baseless. 0 is equals to 3. It's not at all true. It's not at all valid. Okay,
Yeah.
so this approach is not working. Okay, we will be using the H approach of the limit and then we will be saying that left hand limit, right hand limit and the function's value at pi by 2 is same. Okay, so let's try finding the limit. Left hand limit, x is approaching to pi by 2 from x is approaching to pi by 2 from the left side. That means limit h, a very teeny tiny small, very small number h we have taken, which is just close to 0, and f of pi by 2 minus h. Right, Fatima?
Yes.
Let's do it. So limit h tends to 0. Pi by 2 minus h, it will be k cos pi by 2 minus h, right? Over pi minus 2 into pi by 2 minus h, right?
Yes.
Cos pi by 2 minus h is what?
Sin h.
Okay, k sin h. And in the denominator, what are we going to have, Fatima? Please do the calculation and let me know.
H.
Just H or 2H?
2H.
2H. Okay. Now does it looks like this format?
Mm,
The limit is, do we know this predefined limit?
yes.
Limit x tends to 0 sin x by x is 1. Is it so?
Yes, ma'am.
So this approach we have to apply over here. Okay. K by 2 into 1 we are getting, and now we can understand that this is the just the left hand limit. If we'll be taking this is equals to function's value at pi by 2, still we'll be able to find the value of k, right?
Yes, ma'am.
However, we will find the right hand limit also. In complete solution we will not show, so we will be finding the right hand limit also of f of x. That means a very small h we are taking, that is just close to 0 function. It is approaching pi by 2 from the right side. Here also you will be getting k by 2. Okay.
Yes.
Yeah. So here also you will be getting, if you will solve, you will be getting the same scenario. Here instead of this, let me show you. Instead of this pi by 2 minus h, you will be having pi by 2 plus h, right?
Yes, ma'am.
Cos pi by 2 plus h is what, Fatima?
Um, minus sign.
Exactly, minus sign. And in the denominator also you will be having pi by 2 plus h. Due to that, you will end up getting minus 2h in the denominator, right?
Yes.
Okay. And hence we will be able to apply the same limit concept, that is limit x tends to 0 sin x by x is 1, and we'll be getting k by 2. However, our main focus is to find the value of k. So we will be saying left hand limit, right hand limit, and the function value all are equal. That means k by 2 is equals to the function's value at pi by 2, that is 3. We are getting the k value from here, right, Fatima?
Yes, ma'am.
Any confusion over here?
No, ma'am.
Okay, let's continue. I'm not taking the next few questions because there we are just having the polynomials. Kx square we are having, 3 we are having. So there, even if you will do directly, you will be getting the answer, but not for this question. Basically, when we are having sine function or any trigonometric function or maybe greatest integer function, so we will be careful because these functions behave differently towards the left of any angle, towards the right of any angle, right?
Mm,
Okay, so here we will be careful whenever we are having sine, cosine, tangent, cotangent, cosec, sec, we will be using the H method. Okay.
yes.
Yeah. Suppose we are having, let's do quickly this one. F of x is equals to kx plus 1. If x is smaller than or equals to pi, x is bigger than pi, then the function is defined differently, that is cos x. And at x equals to pi, it is continuous, already given in the question, hence find the value of k. Let's do left hand limit, right hand limit, and the function's value at this one. Limit x is approaching to pi from the left side. Okay. Limit x is approaching to pi. H tends to 0 will be taken. H tends to 0. Okay. F of What can be written over here, Fatima? F of what?
Pi minus h.
Yeah, pi minus h. Pi minus h. Which one? Like, what is the function? What is
Kx plus 1.
exactly? It is kx plus 1. So k x is pi minus h. So k pi minus kh and then plus 1. Right?
Yes.
Okay. What are we going to get from here, Fatima? When h is
Mm,
h tends to 0, then what? H is 0. So is it k pi plus 1? Is it so?
yes.
Okay. Now the right hand limit we are finding because the function is continuous at pi. H is approaching to 0. F of pi plus h, and for pi plus h it is cos x or kx plus 1.
Mm, cos x.
It is cos x. Okay. H is approaching 0. Here we are having cos pi plus h will be, if we will change this to the transformation first, what are we going to have?
Minus cos h.
Yes, we'll be having minus cos h, and h is 0, so it will be
Minus 1.
minus. F of pi also we will check. F of pi is k pi plus 1, right, Fatima?
Yes. Mm,
Okay, so we are getting that we will be able to find the value of k from here, right?
yes. Mm,
Okay, let's continue. Now there is a function where it says that f of x is equals to 5 ax plus b 21 if x is smaller or equals to 2, if x is lying in between 2 and 10, and if x is greater or equals to 10. Then we have to find a and b if the given function is continuous function. Okay, the given function is continuous. What can be done over here, Fatima?
mm,
A and b value we have to find, given that the function is continuous. Just that, nothing else. Okay. So if it is continuous function, we will check that what are the point where the function is getting changed towards the left of 2, towards the right of 2, right?
yes.
We will be saying that since the function is continuous function, hence it must be continuous at x equals to 2, right?
Yes.
Okay, we will be saying the given function is continuous. The given function is continuous. Hence, it is continuous at x equals to 2. And we will see what exactly are we going to get. Left hand limit, right hand limit, and the function's value at 2, right? I am writing it over here.
Yes.
Left hand limit of 2, right hand limit of 2, and the function's value at 2. Quick here we'll be writing. Okay, step by step you can do it by yourself. So left hand limit will be 5, right Fatima?
Yes, ma'am.
Okay, here sign and all is not involved. So directly also we can. Right hand limit is
Yes. Me?
yeah ax plus b, and will it be 2a plus b when we will substitute 2 at the place of x
Yes.
while finding the right hand limit? Okay, so directly I am writing it will be 2a plus b. Is it making sense to you, Fatima?
Yes, ma'am.
Okay, and the function's value at 2, it is still 5. So from here we are getting one equation, that is 2a plus b is equals to 5, right Fatima?
Yes, ma'am.
Similarly, we can see the way function is defined. We can see on the left of 10, on the right of 10, the function is getting changed, right? So we
Yes,
will
ma'am.
be saying that since the function is continuous, continuous means everywhere continuous in its domain. So it must be continuous at x equals to 10. Okay, and here we will be again, we will be taking the left hand limit of 10, right hand limit of 10, and the function's value at 10 will be just comparing it. Let's do it. So left hand limit of 10, will it be, can you tell me what will be there, Fatima?
10a plus b.
A 10a plus b. Perfect. Right hand limit.
21.
Perfect. And the function's value at 10 is still 21. So here also we are getting one equation, right?
Yes.
And once we will solve this two equation, are we able to get the value of A and B?
Yes, ma'am.
However, once we saw the question, we were clueless because nothing is clearly written in this question where exactly we need to check. But we understand that the points which is reflecting over here, the important point where maybe if we can get like the function is getting changed, okay, that point we can take, and we have taken those points. We ended up getting two equation, and hence after solving this two equation, we will be able to take out the value of A and B. Any confusion so far?
No, no.
Okay, let's continue. Just a second, let me take the. Now we'll be doing this question. Find all the points of discontinuity of f defined by f of x is equals to mod x minus mod of x plus 2. Let's find the all point of discontinuity from here, Fatima. First, we
Yes.
must understand how exactly the function is defined over here, right?
Yes.
And we have to define the function. So modulus function is defined how?
If x is greater than or equal to 0.
When x is greater than or equals to, it is giving the result as a f of x. This modulus function, not f of x, this modulus function will be x. When x is smaller than 0, yeah. Can you hear me, Fatima?
Yes, miss.
Really sorry. I got something. That's why I had to do. So here we are having this modulus of x, and we understand that modulus of x is defined like this. When x is bigger than or equals to 0, it will just give the output as only x. And when it is smaller than 0, it will give minus x, right?
Yes, miss.
And what about this negative x plus 1? Can you tell me, Fatima, how to define it?
It will be equal to
It will be and
if
whatever
x
is
plus 1,
yeah,
if x plus 1 is greater than to 0, then it's equal to minus x minus 1.
if it is bigger than or equals to 0, then it will generate the result as it is, yes or no?
Yes.
And if it is smaller than 0, then it will give one more minus sign, right?
Yes.
And we can define the inequality like this: when x is bigger than or equals to minus 1, right?
Yes.
and when x is smaller than -1, right?
Yes.
Okay, so let me mark -1 over here. When x is more than -1, then the function is this x plus 1 mod of x plus 1. It will just generate as it is the result. Okay, and when it is smaller than this, then it will generate the result as it. Then it will generate the result as a mod of x plus 1 will be minus x plus 1. Any confusion so far, Fatima?
No, ma'am.
Okay, now let's redefine the given function. Can you see we ended up getting three parts of our real life?
Yes.
This point is okay. How many parts we are having of our real life? Three parts. This is one of the part. This is the other part, and this is the third. Three. We can call it three intervals we are getting, right?
Yes.
Let's define it. F of x got broken into three intervals. That is when x is smaller than -1. Okay, then there is a condition when x is lying in between -1 to 0. Then there is a condition when x is bigger than 0. Then there is a condition, right? Equality sign also we will add over here. But for now, this is what we are getting, right, Fatima?
Yes, ma'am.
Okay. When x is smaller than -1, then this function, I am just doing the calculation over here. Mod of x minus mod of x plus 1 will be what? Mod of x will be, we can see it will generate minus x result. Yes or no?
Yes, ma'am.
The line. And this will generate what result? It will generate the result also minus of x minus 1. Yes or no?
Yes, ma'am.
A minus sign is there in between. So we will be having minus x, then plus x plus 1. Right, Fatima?
Yes.
So the result is coming out as the only one, right?
Yes.
Let's check for the next interval. When we are having in between -1 to 1, then mod of x will still give the result as a minus x, right? Right, Fatima?
Yes.
And this, what about this mod of x plus 1? Will it give negative or just as it is? Can you see the arrow over here? Can you see this arrow, blue colored arrow?
Yes.
So in between -1 to 1, this mod of x plus 1 is generating x plus 1. Yes or no? Without any negative sign. Yes or no? If we will do the simplification, what are we going to get, Fatima?
Minus 2x minus 1.
Any confusion so far?
No, ma'am.
Let's continue. If we will be taking the last interval, that is in between between this 0 to greater than 0, 0 to infinity. So here this modulus of x is just x, and this is also just x plus 1. Please do the simplification part. Tell me what are you going to do.
1 or minus?
Will we get it? Is it minus 1 or 1?
Minus 1.
Minus 1. Okay. So we are getting negative. So far, any confusion, Patrick? Okay, now the equality sign also will be right over here. So here we can see greater or equals to 0 is there. Okay. Now this one we have to be clear. X is smaller than minus 1. This is we are having. And from 1 here will be. Can you see it? Can you see it? Any confusion, Fatima?
No.
Okay, this is how we have just redefined our function. Okay, and hence now we will proceed from here. You will be able to, what was the question? Find the point of discontinuity. This type of question we have done, right?
Yes.
Okay, finding the point of discontinuity. Basically here we need to check at -1, at 0, and just smaller than -1 we can take C. Okay, greater than, or we can directly say when x is smaller than -1, when x is, let's complete it, let's finish it. When x is smaller than -1, then f of x is what? 1. It's a constant function. It is continuous. Yes or no?
Yes.
When x is bigger than 0, okay, then f of x is what? -1. It's a constant function. It is continuous, right?
Yes.
We will be checking x -1. At this point, we will be checking the continuity, and we will also be checking the continuity at x equals to 0. We will also be checking the continuity in between -1 to 0. If x is lying in this range, then f of x is the same, -2x minus 1. Is it a polynomial function?
Yes.
It is continuous. Okay, at -1 we will be checking. Let's check it. Left hand limit. Left hand limit will be just 1, right?
Yes.
Right hand limit will be
Yes.
right hand limit will be
0.
-2, -1. Is it so? Right hand limit of -1, Fatima, be careful. Right hand limit. The function is -2x minus 1, right?
Oh, yes.
Right?
Yes.
So if we will substitute at the place of x -1, it will be +2 -1. That is, the result is 1, right?
Yes.
Okay, and the function's value at -1, it is also just 1, right?
Yes.
Hence we can say it is continuous at -1, right?
Yes.
What about at x equals to 0? Left hand limit. Here main thing is just defining this part. If you are clear with that, then limit you will be able to do. Right, Fatima?
Yes.
Okay, 0 towards the left of 0 we will be doing, and it will be 2 into 0 minus 1. Just negative 1 is the result, right?
Yes.
Towards the right of 0, it will be
Minus
negative 1. At 0, it is
minus
negative
1.
1. So this is continuous, right? Let's check the graph. Let's check the graph. Let me open that. What is the function? Can you see the screen, Fatima?
Yes.
Can you see the graph?
Yes.
Okay, at 0, it's continuous. Can you see?
Yes.
Okay. Yes, without even lifting the pen, we will be able to plot this graph, right?
Yes.
Okay. At minus 1, of course, it is continuous. So yeah, this graph is continuous. Okay.
Yes.
Let's continue. Any confusion so far, Fatima?
No, no.
Yes. Okay. Now the last concept which we need to discuss from here is the concept of composite function. For that, there is a theorem. At first, you need to understand the theorem, then quickly we'll be solving few questions. So let me write the theorem over here. Suppose you can see my screen, right?
Yes, ma'am.
Suppose F and G are real valued function such that f of g is defined at c if g is continuous at c and if f is continuous at g of c, then f naught g is continuous at c. Let's see what the statement of this theorem says. You need to understand it, then we'll be solving few questions. So here it says that suppose f and g are real valued function such that f of g is defined. Okay, the composite function f of g, it's defined. Okay, at c. Okay,
Yes, ma'am.
now if g is continuous at c, g is continuous at c, and f is continuous at gc, then only we can say that this function, the composite function, is continuous at C. What does that mean? It means that if we are having the composite function f of g, can we write it as a f of gx? Can we write it like this, Fatima?
Yes, ma'am.
Okay. So at any point x equals to c, if this function gx, the inside function, is continuous. Okay, at any point c, if this inside function is continuous, and the outside function is also continuous at x equals to c? No, the outside function must be continuous at this input. At this input, if the outside function is continuous for this input and the inside function is continuous for this input, then only we will say that the composite function is continuous at x equals to c. Is it making sense to you?
Yes, ma'am.
Okay, so we are not saying that f is continuous at c, g is continuous at c, and hence f of g will be continuous. No, that we have discussed in the algebra of continuity, that addition, subtraction, multiplication, division will be continuous when both the functions separately are continuous at a particular point. But this is not multiplication, this is composite function. Okay, here we understand composite function means while finding the domain and the range also, we try finding it like this only, that what input we can give for the inside function. Okay, suppose we are having g of x is equals to 1 by x. Okay, and f of x is equals to, let's say we are having sin x. Okay, then f of g x will be f of 1 by x, right, Fatima?
Yes, ma'am.
Okay, so while finding the domain and range over here, we when we are thinking about the domain, we think it like this: what can be given as a input to this function gx? So the our answer is we can give any x value we can take, but not 0. We can take any x value but not 0. So for this gx function, all the real number is acceptable except 0, right?
Yes.
Similarly, now we'll be thinking about f of 1 by x, that means sine of 1 by x, and we understand sine is continuous everywhere. If there is any boundation on this sine also, then we'll be taking both the domains, like intersection we'll be taking, and then that reason we will say this is the possible x value we can take over here. Okay, for since sine is continuous everywhere, we understand, we have discussed it in previous class only. So here what we are saying, here we are saying, Tejas,
Yeah, yes, ma'am.
our class is going to start after 15 minutes. Can you please check
Okay.
the timing?
Okay, ma'am. Sorry.
No worries. So this sine of 1 by x, okay, this is continuous everywhere, so we don't have to worry about it. Now what is the domain of this f of g function which we are having over here? We will say all real number but not 0. But not 0. Okay, because initially only we have excluded 0 from the input part. Are you getting it, Fatima?
Yes.
Okay, this is what the theorem says, that if we are having f of g, then we have to check whether g is continuous at c or not, and f is continuous at gc or not. Got it?
Yes, ma'am.
Okay, now we'll be proving few, like we'll be solving few questions quickly. show that f of x is equals to cos x square is continuous function. What we'll do over here, we will take one of the new function gx is let's say cos x, and hx is let's say x square. Okay. Now if we will find the composite function, that is g of hx, g of h, Sazia, uh, we are having question after a few minutes. Okay, from 45 we are having our class. So if you want, you can wait over here. Am I audible, Sazia?
Yes, ma'am.
Okay, so if you want, you can wait over here. We are having after a few minutes from 45 we are having our class. Okay.
Okay, ma'am.
Okay. So yes, Fatima, what will be g of h? Can you find it? G is hx is x square. That means what will be there, Fatima? Is it cos x square?
Yes.
Okay, this one we have taken by us. Can we write f of x as a g of h? Can we? F of x, can we write it as a g of h? Because we are not doing any changes.
Yes.
So let me summarize what we did. We have taken by ourselves a function. Yes, hint we are getting from the given function, and one more function, so that the composite of both the function is the function, the given function. Okay, now we are going to say, we understand that this h of x square is it's a polynomial function and it is continuous everywhere, right?
Yes.
Okay, it's continuous everywhere. Continuous everywhere. And this cos x is cosine function. It is also continuous everywhere, right?
Yes.
And hence this g of h will be continuous function. That means f of x is continuous function. Getting it, Fatima?
Yes.
Okay, similarly, we are having the next question. Let's say we are having, I'm writing the function. You are going to tell me what to take as a gx and what to take as a hx. Okay.
Yes.
If we are having f of x is equals to modulus of cos of x, what to take as a gx, Fatima, and what to take as a hx. Here also we have to show that it's a continuous function.
Hx can be gx can be modulus.
Gx can be modulus of x and hx can be cos x. Is it so? Then in the rough part, we will be checking whether the composite function is the given function or not. So we are going to check it in the rough part, that is g of hx. Okay, sometime when you will check in the rough part, Fatima, you will realize that g of hx you are not getting as it is the given function is like modulus of cos x. Exactly that you are not getting. But when you are finding the other composite function, that is h of gx, then you are getting the same f of x. Okay, sometime you will be getting like that. Okay, so you can take that composite function only. Okay, whether we are taking g of hx or h of gx doesn't matter at all. Getting it? Getting it, Fatima? What I'm trying to say?
Yes.
Okay, let's check g of hx. Hx is cos x. Okay, Then g of cos x is, yeah, modulus of cos x. Perfect. You identified it correctly. So f of x can be written as g of hx, right?
Yes.
Here we will say that this cos x function is cosine function is continuous everywhere, and this modulus function we have checked already. It is also continuous everywhere. Yes or no?
Yes.
Hence the g of h. Hence g of h. This will be continuous everywhere, or the given function f of x will be continuous everywhere. Getting it?
Yes.
What about the case when we are having, when the given function f of x is sine of mod x, Fatima, then what to take as a hx, what to take as a gx?
Hx can be mod x and jx can be sin x.
Perfect. Now you will be able to do, right?
Yes.
Okay. So yeah, Fatima, this